random variable is a function. What is a function, you may ask? It's a machine that takes an input and spits out an output. In statistics, we refer to these machines as random variables, and we denote them by letters. Most commonly, we use x, y, or z. Okay, now, the input for this function, x, is the sample space, which is the set containing all possible outcomes of an experiment. And that could possibly be the different size of a coin in a coin flip, like randomly getting heads or tails, or perhaps the number of total dots in a roll of dice, like, again, randomly getting a 2 or a 6. Maybe not a 7 because it's impossible to get it. You get the idea. This set of possible outcomes is usually denoted with this fancy Greek letter called omega. But when you think about this, outcomes like these are almost impossible to use when it comes to doing calculations. I mean, try getting the average of 2 heads and 1 tail divided by 3. It's impossible to calculate it like that, right? So, this function's job is to convert every possible outcome in the sample space into meaningful numbers that make sense according to the situation, so that you can do mathematical stuff. So just imagine, I set this head into a 1 and this tail to a 0, and then boom, you're able to calculate the average now. That is the magic of random variables. It quite literally transforms every outcome into a number. Now, if we were to set every input to a number, we get a set of real numbers that the random variable mapped to. That set, denoted as this fancy R, is your output. And there you have it, a function that is ready to be used right at the palm of your hand. Let's do 3 examples to understand this a bit better. Okay, for the first example, let's say I am doing a coin flip experiment. Let's assume that the coin is fair and it does not do some wonky nonsense, We say, let x be a random variable that measures the number of heads appearing in 3 coin flips. Okay, so what does this even mean? Our input is the sample space. What random outcomes can we get? In 3 coin flips, we can get tails, 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 or we can get 1 head and then 2 tails. We can even perhaps get 3 heads in a row. You get the idea. When flipping a coin 3 times, it's possible to get one of these 8 random options. Okay, so again, how can we do any calculations with this? We need x to convert these outcomes into numbers, but what numbers do we choose? Luckily, the question stated x to measure the number of heads. So that means we look at these different possibilities and we just count the number of heads, which in this experiment, we can get 0, 1, 2, and 3 heads. And there you have it. That is what your random variable is set up to do. The great thing is you can even test out this function. Try inputting tails, tails, tails into x, and x should always spit out 0 heads. Okay, here's a slightly harder example. Let's say we are doing a dice experiment, specifically rolling 2 fair dice. Let y be a random variable that squares the total number of dots from both dice. Again, so what does this even mean? We think about the input first, which is obviously our sample space omega, right? So what are the different possibilities or outcomes that can occur in this experiment? We can get 1 and 1, or perhaps a 6 and 6. Anytime you roll those 2 dice, we're going to get one of these 36 outcomes. That's a lot of outcomes, and it's taking up too much space. So let's use some fancy math notation here and replace it. Next, we think about what we output. It says in the question that y squares the total dots. So what are the total dots? That's just adding the 2 numbers we get, I plus j, where I and j can be any number between 1 and 6. Then we just square it. So the actual output set is the numbers we plug in into this equation. For 2 dice rolls, the possible outcomes according to this equation are this set. And there you go. Okay, so I want to actually test this out. Do me a favor and roll these 2 dice for me, bro. Congratulations, you get a 64. Okay, last example. Suppose you're at a bus stop. Let x be the waiting time of the bus between 0 minutes and 10 minutes. So by now, we know that the sample space is the possible outcomes, right? So that means you can either wait 1 minute or 2.5 minutes or 0.59999. I'm not going to say all these minutes. I don't know. It can be any number between 0 and 10. What about our output? Since they're already numbers, we don't have to convert anything. Just leave them as it is. And boom, there you have it. Let's test this out. Okay, so apparently my transit app says the bus is going to come in 0.001 seconds. And there you go. Hopefully you guys don't run into any issues now with random variables, right? I explained it pretty well. Have fun calculating all that nonsense.